Okay, we factored already with quadratic trinomials when a was equal to 1. Today, factoring pattern ax squared plus or minus bx plus minus c. So again, a quadratic trinomial. But now when a is not equal to 1, it's a little bit different. If a was equal to 1, two factors of c that add up to be b, and then we write them in the quantities. When a is something other than 1, we have to do a little bit different process. So here's how it goes. It's called the AC method. Crazy name, I know, because we use A and we use C to set the stage for the whole thing. The AC method. So step 1, you are going to multiply A and C. So the product of AC. Multiply them together, we'll get some number. After we do that, we're going to find two factors of this answer we got from taking A times C and check that they have a sum of B. So similar, whatever this number is, two factors, and they have to add up to B. Now, we just don't write these in quantities. Now we have to go through and use these factors and rewrite our linear term. Linear term is the one that's raised to the first power. So that would be whatever plus or minus it happens to be, bx. So we'll write it like this. Here. So it's now going to produce four terms for us when we rewrite it. Or if you want to look at it this way, we started off ax squared plus or minus bx plus c. We took a times c and got some number. We found two factors of that number that add up to be b, so we write one of the factors here, the other one here. Depending on the sign, that goes back to the last lesson we had in using those. So that gives us 1, 2, 3, 4 terms. Now the x is in both of these. This is x squared, this is our constant. With 4 terms, that goes back now to stuff we've already got in our notes, and that is factoring by grouping. We already have that in our notes, so we're going to follow that procedure, and that's going to get us through this. So what are we doing? We're turning a new problem into something we've already learned. Something new using prior knowledge. So let's go through an example here and see what we come up with. So staying true to my notes, I am going to factor this quadratic trinomial. Quadratic term, linear term, constant. So it's already in standard form for me. I see A is something that's other than 1. There's B, there's C. So since A is something other than 1, I follow the process that I just put in my notes. Step 1, multiply A and C together. So off to the side, I show my work. I write AC down, and I take that product. So that's going to take a 7 positive times a positive 4. Answer, 28. So I need two factors of 28 that add up to be 29. Well, I don't have many choices. 1 and 28, 2 and 14, 4 and 7. So as I look at my factors, 1 and 28 happen to add up to be 29. Both positive. Good. Now what if that was a negative 29? Well then, that could be both positive, or I could have my negative list over here. I saw positive already, so I knew what I wanted to deal with. If that would have been a negative 28, either negative here, then you would have had one of each sign. Again, stuff that's in your notes. So I'm going to do this and follow my notes. Two factors to have a sum of b. I've checked that, so I'm through step 2 already. So I'm down to here, rewriting. As your notes say, nothing happened to the quadratic term. We're rewriting this using these two factors. Whether I want to use the 28, whether I want to use the 1 first, that's completely up to you. I'm going to choose the 28 first. 28x plus x plus 4. So like I did here, just split it up here and here. That stayed the same, that stayed the same. Look, 29x split up. Stayed the same, stayed the same. Some people put a 1 here. If you want to, go ahead. So now what do I see? I see grouping going on between my two terms. So what's my GCF between these two terms? That's going to be a 7x. So it gets factored out. Divided by 7x leaves you with x. Divided by 7x leaves you with 4. Ah, I've already got that quantity here, don't I? I don't have to do anything to it. Now remember, in terms of multiplication, if there's nothing in front, what's not always there? A 1. Common, quantity of x plus 4. Factored out, in other words. What's left? What's left? Remember, some people might have this written out as a quantity of 7x plus 1 first, quantity of x plus 4 last. Those are the same answer. Okay, well, let's look at this example. Again, it's called the AC method for a reason. We're using A, we're using C, and it all starts with that being something that's not 1. It isn't. All right, so I go to my AC work over here. I'm going to take 3 times 20 and get 60. Potential for factors. Now, let's work smart. Let's work efficient. I got a positive 60 here. That means I'm either going to have positive factors, both positive, or both negative factors. Negative times negative is positive. We need this. So, with that being said, do I need to go through and list the positive factors? For those of you that answered no, you are correct. So, let's go here. 1, 62, 30, 3, 24, 15, 5, 12, 6, 10, 7, not so much. 8, don't think so. 9, not going to happen. 10, and now we're back into our repeats. But what I forget to do, they're all negative factors. Negative times negative is positive, but we got to have a negative b term. That's why we chose this. So we need 2 of these factors that have to be negative 17. Our answer comes in that right there. So let's rewrite. So I'll have my 3x squared. Now, what am I going to do next? I got a couple choices. Let's just take them the order that they're in this time. So I'll go minus 5x, minus 12x, plus 20. Remember, as we're doing problems like this, when we group, which is what we're trying to do, I want a plus sign in between my quantities. So there, I want that negative to go with the 12. So I do this. Add opposite. Same thing as subtracting. I like to do that because now I got my signs where I want them and I don't have to worry about changing anything in the end. So I look. What's a common factor between 3x squared and a 5x? If you said x, you are correct. Factor it out, leaving us with 3x minus 5. That's my key as to what I got to factor out here. I need to have a 3x minus 5 out of this. So in other words, this has to be positive, that has to be negative. Their signs gotta change. So what's that mean? We're going to factor out a negative number. Negative 4 is common in between both of those, so we factor out 3x, positive divided by negative, minus 5. We got our common factors again. So 3x minus 5 was common. It's been factored out. What's left? And x minus 4. So now that has been factored. Good. All right, our next example. Now, as we get farther and farther into these things, we're going to have to realize that sometimes things aren't factorable. They're considered prime or not factorable. It's not always the case. It does happen once in a while. So before you go and say, well, it's not factorable, make sure you explore all your possibilities. And that's what you'll see in instructions. Sometimes they'll throw the phrase if possible in there. Doesn't mean it's always going to happen. They're just covering their trail in case it does happen. So let's look. All right. Quadratic trinomial, check. A is something other than 1, so that means AC it is. So we got to take 4 times 5. We get 20. So we need two factors of positive 20, but they got to add up to be what? Negative 3. So what's that tell us to use? Both positives or both negatives? Correct answer, both negatives. So negative 1, negative 20. Negative 2, negative 10. 3, no dice. 4, negative 4. Negative 5, 6, not happening. 7, nope. 8, nope. 9, nope. 10, now we start our repeats. So these are our factors. What do they have to do? They have to add up to be negative 3. Add those up. Negative 21. Add those up. Negative 12. Add those up. Negative 9. All right, now, before I go and say, well, I can't factor this, it's not possible, please explore. Make sure you got the right sign here. Make sure you're looking for the right sign with what you're doing. Explore all your options first. But as we look, that's not negative 3. That's not negative 12. Or I'm sorry, that's not negative 3 and neither is that. So in this case, if your directions say not factorable prime, then we write it out. This will be considered a prime trinomial or not factorable. In future lessons, you will learn how to solve these certain ones, but this particular method doesn't work. So our AC method, very similar to quadratic trinomials, just got to go through the AC part of it.